Thank you, everybody. How are you guys doing today? Just one woo? I'm already disappointed. All right, let's get this going. I'm Alex Lynd. I am Alex Lynd. I'm really excited to share with you guys how I use microcontrollers in my projects to build low-cost hacking rigs, and more specifically highlight their merits when it comes to covert applications or potentially scenarios where you need disposable hardware, because this is perfect for that. So microcontrollers are kind of a divisive topic, and you would know this if you've ever visited the comment section of any Hackaday post. So as much as I would like to remain platform agnostic with this presentation, I'm a huge Espressif fanboy. Most of my work uses the Espressif family. And kind of the advantages are front and center. These are wireless focused chips. They pack a lot of power into a relatively small form factor. You can get these for about $2 to $3. It's pretty awesome. And their newer chipsets also offer some other really great functionality for potential use cases in physical exploits like the USB stack. And they also support some other things in the ISM band, like Bluetooth, Zigbee, all sorts of fun stuff. So for a short background on myself, as far as it's pertinent to wireless hacking and sort of how I got where I am today. So I sort of found my interest in this stuff like back in middle school. Growing up, my parents couldn't afford to get me a computer, so the first computer I bought myself was a Raspberry Pi. And I went down this rabbit hole of learning about Wi-Fi hacking and reconnaissance and war driving and all this other fun stuff. And over the course of like a couple months, I ended up taking a couple spins around my neighborhood, cracking Wi-Fi networks and stuff like that, because I was tired of having to go to Starbucks every time I needed to submit a school assignment. So that's kind of what piqued my interest in how I discovered this sort of niche. And then from there, I always just had a love for hardware. I just started building like Raspberry Pi rigs. This was the first one that I created. It's just a Pi with a TFT and a couple other components slapped on for reconnaissance. Started building a lot of other stuff with Raspberry Pis, but you can imagine that this got really expensive really quickly. And I took this picture this morning, but I have like a graveyard of electronics, and these kind of terrible, like mutilated Raspberry Pis. Oh shit. We're not gonna watch that. That's a testament to some horrible experiments and also, I guess, the scientific method. But you can imagine this got pretty expensive and kind of speaks, I guess, to my 2016 privilege of having access to these things before they were rarities. But when I was going down the hardware rabbit hole, I came across microcontrollers. There's a really cool researcher and embedded developer named Spacehoon. He makes projects like the Author and a lot of other microcontroller-centric projects. So this was kind of eye-opening for me to see that there were these low-cost tools that existed that I could use for single-purpose applications, where if I wanted to build a device, I could just power on, have it perform one task well, like gather reconnaissance or something. I didn't need a full-blown Linux system. And also, like from the perspective of forensics and stuff like that as well, not having a full file system can sometimes be beneficial because there's a lot less holes to poke. There's a lot less areas where you might be complacent about security if you don't have to secure a whole bunch of stuff. So I'm going to introduce what some of those merits are in this presentation. So where am I now? I'm a hardware hacker and hardware developer. My primary interest and domain is signals intelligence, Wi-Fi hacking, everything of that sort. So I do a lot of contracting for IoT companies. I build products. I mostly do rapid prototyping and that kind of thing. And when I'm not doing that, I develop proof of concepts just for fun, some of which I'll show you guys today. And I'm also a cybersecurity content creator. So I've made videos for channels like Hack5. I appear on various podcasts and shows and random things people invite me onto. And I like to integrate my work as much as possible. I like finding intersections of the different things that I'm interested in. So one of the things that I like to do with my content, and this is also sort of where I'm going to apply like an educational lens to this presentation, is the hardest thing about content creation is grabbing people's attention. So finding novel ways to do that can can be difficult sometimes. The way that I like to do it personally through my content is by building an interesting narrative around hardware. So with these low-cost rigs, even though sometimes they might not be the best for a hacking engagement, being able to say that I was able to do a hack for $15 compared to, I don't know, someone who has like a full-fledged Linux system or like a fully spec'd out rig can be impressive, and it provides an interesting plot point for the videos that I'm creating. It also provides an interesting narrative if you're watching it when you get to see me build the rig and see all the components and work that goes into it. So that's just personally my style, and hopefully I'll get to share some of that through this presentation. These are some products that I've made. I don't think I have time to talk about them. My favorite right now is this Astral Heart earring design that I'm working on. It's a little reactive circuit board that blinks with a pulse oximeter. If you guys want to learn more or hear about any of these projects, you can accost me after. All right, let's get into microcontrollers. Why? So the advantages are kind of obvious. Microcontrollers kind of offer a good middle ground between like microprocessors or an ASIC, right? And I'm sure most of you guys know when you might select one, like the appropriate use case for your projects, or at least I would hope so. But the reason why I choose to use microcontrollers for my projects doesn't really differ that much from why you might select one. So right off the bat, the why. Nice. So microcontrollers, from a hacking rig perspective, offer a good middle ground between something like a Raspberry Pi, a full-blown Linux system that you need to configure and all that fun stuff, and more tailored or application-specific tools like maybe a Hack5 product or a Flipper Zero that are designed for specific types of engagements, like a Wi-Fi Pineapple, a Ducky, or things like that, where they're also not designed to be modified. Microcontrollers offer a great middle ground when it comes to extensibility and being able to have full control over your hardware. And in terms of the actual attributes, cost barrier, and supply chain and availability are all things that are kind of intertwined and pretty much the first thing that anyone is thinking about when approaching a project. We all saw how like Raspberry Pi got nerfed during the chip shortage and quickly rebounded with the Pi Pico. And also like the reason why I choose to use espressive chipsets. I have a friend that like works on a project that's based around the ESP32, and in anticipation of the chip shortage, he bought a crap ton of them, expecting them to tank. Not even a hiccup. They did very well in terms of resilience. So cost barrier, whether you're someone that's building a fleet of hacking devices, or if you're just a person that's creating a one-off prototype, or maybe you're a student that is trying to build one of these rigs to learn about like one of my demonstrations, for example. Cost barrier is always something that's kind of front and center, and also the availability. This also kind of ties into the other two criterion that I have for disposability and form factor. When I'm building these rigs, these are something that I really have to think about. There's just some scenarios where you can't just plug in a Raspberry Pi, it's too conspicuous. But there's a lot of other places where you would be able to embed a microcontroller inside of a USB charger, for instance. And also on the note about disposability, these things are so cheap that if you do end up letting the magic smoke out of them every once in a while, like, it's okay, they're $3 to replace. So let's talk about the actual things that I've made. So this was the first microcontroller hacking project that I created. It's called the ESP bug. And you can see it's kind of inspired by Sammy Kamkar's key sweeper, if you guys have seen that project. But this was basically an ESP8266. The form factor is an ESP01. You can buy this for $2. I embedded this inside of a wall charger. I did not know what a low dropout regulator was, so I used 2 resistors as a voltage divider, hooked directly up to USB. I made this when I was in 8th grade. Please don't judge me. It was terrifying, but what's awesome is for $2 to $3 of silicon, $2 to $3 of silicone isn't going to get you far, but $2 or $3 worth of silicon, this is pretty amazing. I was able to bake in a full-fledged web interface that lets me monitor nearby Wi-Fi devices. I could see what networks they were joined to. I could run attacks and things like that. And I recently revisited this project and added some new updates, like You could get an alert over email if certain people are walking in and out of the area, or text updates via Twilio. The original application for this project, though, is, I'll share something personal with you guys. This is a little bit sad. My parents were separated, and I wanted to see when my dad was like in his office, so I could go over and visit him. So I made this device so I could see when his cell phone was in the area, so I could just go over and say hi. It's kind of ridiculous, but I feel like this one highlights the form factor criterion and also the low cost point. I mean, this thing was basically spare change for me. In a similar vein, Wi-Fi theories. I've had this idea for the longest time. And I mean, you can imagine the implication when it comes to building a low-cost fleet or army of microcontroller devices you could just litter everywhere. Or I don't know, maybe build an evil mesh network of, like, I don't know, your own surveillance network or something. But I actually built this a week ago, so I could talk about it here. But this one I took a step up. I used the ESP32, which is comparatively more capable than the 8266 when it comes to reconnaissance and also some other types of attacks. So I found this interesting project that allows you to actually perform full packet capture with the ESP32. Its predecessor wasn't able to do that. So you can actually use this thing to intercept full Wi-Fi conversations instead of just the packet headers, which tell you about like devices in the area or things like that. So I was able to use this to capture a Wi-Fi handshake from IP cameras outside of my girlfriend's apartment. It's not like hers, it's the landlord's, and I want to see like what he's watching. I don't know. He might be a pervert. But I didn't have like a lot of hardware on me. This is what I ended up building. It's an ESP32 I had in my backpack, a LiPo battery that I found from a vape pen that was discarded on the side of the street. I ripped apart a USB cable to wire this to a micro SD card adapter I had in my backpack, and then this morning I added this little enclosure on it so you'd have an idea of what a throwable device might look like. So if you're wondering about the actual feasibility of this, if you're a pen tester, or even why you might want to consider using microcontrollers for your engagements at all, the short answer is with the prevalence of shitty IoT products, sometimes the covert implants are already baked in. And there's a lot of online documentation on how you can buy one of these ubiquitous smart plugs or smart light bulbs and easily reflash them for home automation or something similar. Thing is, with these $2 prototype kits you can buy off Amazon, you can essentially test bed this yourself, I don't know, develop that mass surveillance network, buy a bunch of these light bulbs, ship them out to your neighbors or a corporation or something like that, and then boom, you're ballin'. So, food for thought. On that note about like social engineering, this is one of my favorite attacks. It's called war shipping. So the premise is you can basically create a wireless payload, put it inside of a box and address it to a non-existent person, and ship it off to a corporation. What happens is it'll sit in their mailroom, gather recon, and then be shipped right back to you. So I was able to do this proof of concept for about $10. There's a bunch of other fun things you can do with this. I developed a rogue access point that actually performs the authentication on clients on a hypothetical corporate network, makes them join my malicious access point instead, and harvests their corporate login. So this was a demonstration. This wasn't actually used in a pen test or anything like that. But it kind of pushed the limits of what's possible with these chips, and I guess also pushed the limits of what's possible on YouTube because we had to take this video down. So yeah. One thing you might notice across my projects is a lot of them are using the exact same hardware. I have the same Wi-Fi chips, GPS modules, things like that. And there's not a lot of variation, and that's deliberate, because from the perspective of a beginner that's watching these tutorials, the consistency or the ability to just get up and off the ground running with something you've already built before, I kind of value that. Like if someone's already followed one of my projects, I want them to be able to use it, again, consistently across different things that I make. So I've built a lot of war driving rigs. This is one of my favorite demos that I did with it. I used it for a war flying application where basically we flew like a couple miles of a diameter around a park and used this to precisely pinpoint the location of a friend that we had set up. And this was extremely impromptu. These are also some components I had in my backpack. when we came up with this idea, and I literally gnawed through a USB cable, stripped the 4-core wire with my teeth to throw this together, and it worked. And this is what I value about microcontrollers. They're really easy to set up, and cool, and awesome. Also, don't mind the pervert emoji in the left corner. No. No, we're not. Not today. Okay. So this is probably the only defensive application that I've actually ever built. So this one was also designed as an educational demonstration. And I guess I'll also pivot on this point to talk about how I actually use these from an educational perspective. But the creep detector was a project that uses war driving in an interesting way. I wanted to showcase why the average person might be interested in Wi-Fi hacking or reconnaissance or even something niche like war driving. And it wasn't until recently that I actually ported this over to a microcontroller so I could actually talk about it. The original demo used a Raspberry Pi. But again, this is an example where I was actually able to use hardware as an interesting plot point and built it over the course of the episode to showcase an interesting application that the average person might be interested in. Like, oh, I am able to take a look at this data and determine if someone's been following me by looking for the unique hardware address of their phone, for instance, if they're not using MAC randomization. A lot of you guys might be thinking that that's a hole in the research, but there's actually some machine learning stuff that I'm currently looking into that's able to defeat MAC address randomization. But I'm going to save that for a future presentation. So the next project, I guess before you go singing my praises, the next project diametrically opposes all the good that I've put out with this one, and it's called DNS Drive-By. It's a creepy tracker. So this proof of concept was really fun to make. I also made this for a video demonstration. And what it does is it uses Wi-Fi as a low-cost alternative for tracking. So if you look at off-the-shelf trackers you can get on Amazon or something like that, they typically use LTE or a SIM card module to provide remote updates. Some research that I found online, specifically Kaspersky, and also I looked at Wiggle statistics and other data sets that I gathered in dense enough urban areas. It turns out 20 to 25% of networks around us are completely open, which means you can arbitrarily connect to them. So what that means is 20 to 25% of the time, if you're just driving past, you have enough of a linkage where you can connect to that network, send out a single request containing GPS information, and you basically have a really low-cost tracker. Yes, there are creepy ways that you can use this. But like most things, I feel like security research is kind of a double-edged sword. One principle that I don't really stand by is security through obscurity, for instance. So with this demonstration, I feel like it was effective in presenting this in an interesting way to a larger audience. It's definitely attention-grabbing when you have a $15 device that's able to do tracking like this. So I feel like this effectively brought in an average audience and could be used to potentially educate them on why they should care about these issues rather than standing on a stage and saying, hey, this is why you need MFA. This is why you should delete open Wi-Fi networks from your phone or something like that. And where was I going with that? I forget. But yeah, this one was a little bit creepy. It kind of towed the line. But at the same time, I feel like that's kind of necessary in the security world. Because if we aren't making these things front and center and accessible for the average person to see, then people are going to continue to be complacent about security. And things as simple as Wi-Fi networks or standards that have been around for decades are going to continue to just exist unchecked. If you guys want to learn more about this, I did a whole write-up. I don't really have time to talk about the rest of the nitty-gritty details of the project. But if you're an embedded development nerd, you guys can go read about my whole journey creating this project on dnsdriveby.com. The blog page links to a Hackster article that I wrote. Okay, so I actually got through this quicker than I thought I would, which is great. So this should leave some time for questions. But I'm going to close out with some final thoughts here. And also, I guess, a short projection on the future of my projects and also where I see that standing in a rapidly evolving integration of industries. I feel like the embedded industry and the security industry and machine learning are all growing together really fast. And as a hardware developer, keeping up with all that is really hard, so I'd like to maybe share some thoughts on that. Shortly stated, where do I see my projects going? I would like to learn as much as possible about a lot of different things. I would like to explore the wireless domain more, for one, and also see what some other chipsets have to offer. Like one of the ones that's been on my radar for a while is the Pi Pico, not just in the domain of, I guess, wireless and signals intelligence, but also for physical exploits. Like the Pi Pico packs a lot of punch. Like the USB stack offers some pretty interesting things that can be used for physical proximity-based compromises. I've seen some cool random hacks for like HDMI and Ethernet and that type of thing, which the Pico has native capability for. Nordic Semiconductors, that one's kind of obvious. They offer a line of products that are extremely comprehensive and capable in the RF functionality. While they don't really sit at that low price point, I do feel like I would like to explore other IoT protocols and hopefully explore ways that the security standards, I guess, could be improved there. So other things in the ISM band, namely Bluetooth, Zigbee, and some other IoT protocols. So this one might come as a surprise to Joey. Is Joey here? Joey Castillo? No, he's not. Okay. So this one kind of reflects, so this one's kind of an internal reflection, but I attended a really phenomenal talk at Teardown in Oregon. This was a conference that was put on by Crowd Supply. And this was a really eye-opening talk for me, actually. So in this presentation, Joey pretty much, if you guys don't know him, he's the creator of the Open Book and SensorWatch and a bunch of other really cool projects, and I believe he also did a workshop last year. But he talks about just juicing the absolute shit out of his microcontrollers in terms of the onboard peripherals, utilizing the low-power hardware, and a bunch of other stuff that you might overlook in a data sheet. And it really highlights that as microcontrollers are continuing to get more and more advanced for a much lower cost, and I guess like also as we're sort of starting to like hit that asymptote of Moore's law and what's possible to cram into like a 1 centimeter die, that if you're able to maximize the resources you already have in front of you, like that's golden. And I really don't know a better hardware platform to talk about that than like Joey's SensorWatch, which is extremely size constrained, power constrained, cost constrained. So I'd recommend that you guys check this out. And I guess this would also be a good time to close. I had other slides that I was planning on getting to. But sort of in this day and age, as developers, I feel like we're extremely lucky with the amount of platforms and resources that we have at our disposal. What I was going to talk about briefly was, no, stop playing videos. What I was going to briefly talk about was how I want to get more into machine learning. Also shout out to Edge Impulse, my boy Sean Heimel back there. But it's crazy that something like machine learning has trickled down to a point where as developers, it's not only accessible to us, but extremely easy to use. The fact that I can go into a web interface, create predictive models that I can run like natively on a microcontroller, that's extremely fascinating. So the broader implications that I took away from this particular presentation, I guess, was that, also this is completely like off the dome, so I'm stumbling through it a little. The broader implication that I took away from this was, I guess, that like the hallmark of what makes someone a good hacker is if you can assess and maximize the resources that you already have in front of you to create something functional and beautiful. And this really made me reflect internally, like not just on hardware, but also in life as well. So like one of the goals with the hardware that I'm creating and the presentations that I'm doing is for other people that don't come from a background where they have the privilege and access to resources, I kind of see it as my goal to provide free and open resources and make this stuff as accessible as possible. So other people that came from a background like me can see like, oh, if this guy was able to do it, maybe so can I. And I don't know, maybe I'll leave it there. Thank you, I'm Alex Lynd. Okay, so I actually cut that short. I had some extra slides. But we have 5 minutes. It's up to you guys if you want to see those slides or if you guys would like to ask me any questions. The other thing is I also have some free stuff to give you guys. So my sponsors, PCBWay, gave me a ton of swag to give out. But I didn't bring my development kits today. If you guys find me tomorrow, I'm giving out 20 free development kits of these cat-themed boards that I develop. If you guys want to check that out and support me, I'll be giving out stickers and cards at the end. And then tomorrow, I'll be giving out free samples of my product. And then also, yeah, meet me around. I'll be giving out free PCBWay swag. Does anybody have questions? Yes.
I wonder what your thoughts are on, thank you very much. I wonder what your thoughts are on as microcontrollers get more and more tightly integrated with other functionality. Like, what if they bake the exploits right into the chip itself? Like, do you have any thoughts on that, like a supply chain attack, something along those lines?
I mean, we've definitely seen cases of this before with like routers or things like that that are coming directly out of China that are being shipped with exploits. Wait, your question was just my general thought on the possibility of it with microcontrollers?
Exactly. I'm pretty naive in that domain, so I just wanted to know, do you see anything on the horizon where that's increasing or, danger? I don't know, just your general thoughts.
Well, that's what's kind of great about microcontrollers, just the level of control that we have over them. I think unless it was like baked directly into the silicon die itself with a hardware backdoor, I don't find it that feasible because you can just directly like overwrite the flash right when you get the thing. And oftentimes as a developer, you're buying just like the raw microcontroller. So it's like there's no integrated flash or whatever. Really the only issue that would be present is if you're buying a fully assembled product. That's the only thing that I'd be able to see.
Can you share a little more about your journey going from a Raspberry Pi to something like an ESP32 and some of the skills that you had to learn to be able to translate into the hardware domain?
Let me try to think through this linearly. So I was definitely a bit of a script kiddie starting out. I was just on YouTube watching every Indian tutorial I could get my hands on. And I didn't really know much of what I was doing. So that kind of frustrated me. I like really understanding the nitty-gritty, not just like doing something surface level. So I started looking into like how Wi-Fi packets actually work at a protocol level and things like that. So I just started watching like more and more sophisticated videos. Just got like really in over my head. That's sort of how I ended up at least in this domain of Wi-Fi security. I guess the transition from like Raspberry Pi to microcontroller also probably happened a similar way. I was just watching videos on YouTube when I discovered this embedded developer who makes microcontroller-based projects that are typically used for like deauthing or like Wi-Fi attacks or stuff like that. And I was like, damn, that sounds interesting. Like if I could do this for a fraction of the cost, that's really freaking cool. So I also just like, I don't know, really put my head down in that. Like I wanted to learn as much as possible down to like bare metal. And that's one of the slides that I had saved for the end, which is that as I'm starting to explore more of the capabilities that are within the chipsets themselves, because until I watched my friend Joey's talk, I didn't really, I hadn't really like read over spec sheets to be honest, but the first thing I did when I went home was I just pored over spec sheets. I looked at ways that I can improve my personal projects, and I learned about a lot of really cool hidden features like in Espressif itself. Like I didn't know that there's a dedicated encryption core in the ESP32, or that there's all these secure boot functionalities or things like that. But one of the things that I was going to share is my journey now is I'm trying to work more on the development side of things. So I'm currently contracting with a company that does security for embedded devices, and I'm trying to get more low level. I'm trying to develop on the consumer side of things and the product development side of things. I feel like I lost the question a little bit. Does that address it, or, okay. I'll take 1 or 2 more questions. Yes.
Thank you. Do you have any interest in non-Wi-Fi radio applications? Do you see any of those non-Wi-Fi radio applications?
No Wi-Fi.
Non-Wi-Fi, so anything else?
Yeah. I think that's something I mentioned briefly, but definitely other ISM band stuff. Bluetooth is probably the next one on my radar. The thing that I was going to talk about with machine learning is I think wireless research could offer a really cool dimension to any machine learning studies, really. I think there's like some non-intrusive ways that we could use this for like flow metering or even city planning or things like that. Because I mean, what's the most ubiquitous like thing that we have on us besides our personal biometrics? We have smartwatches, headsets, phones, things like that. So I'd like to explore like Bluetooth, Zigbee, those kinds of protocols. I've always wanted to do radio, like I see you guys wielding your hack RFs and that type of stuff. It's been outside of my budget, but once I do have the opportunity to mess around more with SDR or that kind of thing, I would absolutely love to. For me right now, it's just a time and cost constraint. One more question.
As you get more into the development side of things, what do you think are some of the best practices that new developers should learn in terms of security?
To be honest, I'm a little bit fresh here. And that's why I try not to sell myself as a professional. I by no means am a professional. I'm a beginner who's trying to teach as I learn. And that's what I try to do with my videos. So I am pretty much new to the low-level like embedded development side of things. In terms of security practices, I'm not really sure, but I can give you the product pitch on what we're working on, and it's pretty damn cool. So as I said, it's really fascinating that as developers, we just have access to libraries and platforms and all sorts of things that are just like really easy and even free to use right out of the box. So embedded development has kind of been an area that's been overlooked for decades. There's not an existing standard or frameworks for securing them. So I started working with Thistle just because they're super fascinating. It's Windows Snyder's startup. She's really awesome. And they're essentially just building a framework where right out of the box, you don't have to worry about security. If you're doing over-the-air updates, it's encrypted. There's an online web interface that you can use to remotely push updates to this thing. You can do secure boot right out of the box, so you don't have to worry about like arbitrary firmware being loaded. There's encryption tools that are baked directly into it. And we're currently supporting Zephyr OS and starting to move towards Arduino as well. So I definitely recommend checking this product out, but I'm sorry that I don't have a full answer when it comes to that. Hell yeah. I think I'm probably at my time. Okay. Thank you guys. Free stuff. Come get it.